Question 3. A wedge of mass 3 kilo rests on a smooth horizontal table. One of its faces, which is smooth, makes an angle of 45 with the horizontal mass of 1 kilo placed on the face of the system. Find the acceleration A of the wedge, F of the particle, and resolve them in these vectors to show that the actual acceleration of the particle is of this magnitude. Okay, let's do a sketch of what's going on here. 45 degrees. My particle of 1 kg. I got the acceleration of my particle is going to be F going down, and the wedge will be A going to the right. I can put in my 1g here. I can put in G. What's the mass of my wedge? 3g. I always have a reaction between the wedge and the table. It doesn't come into the context of this question. And I have the reaction between the particle and the wedge, my OR, going up and going down. So that's what's going on here. Let's look at these individually. And let's look at my particle. So I've got 1g coming down, just g. 45. So coming down in this direction, I have g cos 45, which is equal to g over root 2, parallel to the slope g sine 45, which is also g over root 2. And I've got my OR, and I can get my accelerations. So my acceleration, we need to resolve these accelerations down this slope. We said F coming down this way. F. So let's see what's going on the other direction. So we have A is this direction. A. We have 45 corresponding angle in here, which would correspond to the one that was down here. My right angle is over here. So over here I'm going to have A sine 45, or A over root 2, and over this side I'm going to have A cos 45, which is also A over root 2 for my accelerations. So the acceleration in this direction for my particle is F minus A over root 2. And in this direction down here, perpendicular, it's going to be this A over root 2. So let's look at my forces. I'll go with this direction first. What have we got going on here with the particle? We just have my g over root 2. So g over root 2 is equal to ma. It's just 1 times my acceleration, which is F minus A over root 2. We leave it like that for now. Come back to this one in a minute. We resolve it perpendicular to the slope. What have we got going on perpendicular? Well, we have this g over root 2, and we have the OR. So g over root 2 minus OR, we're going down into the block, is equal to m1 times the acceleration, which we said was there, look, A over root 2. So now we need to use the wedge to get this equation for OR. So if I draw my wedge and get an equation for OR, here's OR here. So it's coming down this way, OR here, but the block is moving in this direction with an acceleration of A. So we need to bring our lines down and get what's going on in this direction here in terms of OR. We have our 45. So over here is going to be OR sine 45, which is or over root 2. And over here it's going to be or cos 45, which is also or over root 2. So if we resolve the forces for the wedge, F is equal to MA. The force is going to be or over root 2 is equal to its mass, 3, we had it here, 3, times the acceleration, which is A. It means that or is equal to 3 root 2A. And if or is equal to 3 root 2A, am I finding or somewhere? Or is equal to 3 root 2A. Where was my first equation? Should have put a box around it. Here we go. Or couldn't have been closer to it. I couldn't find it. Or is equal to 3 root 2A. So G over root 2 minus 3 root 2A is equal to A over root 2. So now multiply by root 2 to get G minus 3 by root 2 is 3 by 2, which is 6, equals A. So G is equal to 7A. So A is equal to G over 7 meters per second squared. That's A. We got somewhere for G. Where's the easiest place to solve for G? Well, we just use this one here. G is equal to 7 times A. We want to solve, sorry, for F. G, F. So G over root 2 is equal to F minus A over root 2. So F is equal to G over root 2 plus A over root 2. So F is equal to G over root 2 plus G over 7 root 2, which is G over 7 over root 2, G over 7 root 2. So we have 7 root 2 G plus root 2G over 7 root 2 root 2, which gives 8 root 2G's on top. On the bottom, 7 by 2 is 14, which gives us 4 root 2G over 7 meters per second squared. For F, you can solve that down quicker if you want. And what we asked here, we're asked to put them into vector form, aren't we? By writing A and F in terms of I and J, and then adding, so we want A plus F in terms of I and J, show the actual acceleration of the particle is 5G over 7. Okay, let's look at this in terms of I and J. Okay, let's write down what we see here. We have A, G over 7, and we have F, 4 root 2G over 7, and we have a 45-degree angle in here. So that means that the vector going in this direction, we have the hypotenuse here, and because the angle is 45, we can call these two sides x to get this negative vector. So we can have x squared plus x squared is equal to 4 root 2G over 7 to be squared. 2x squared is equal to 16 by 2 by G squared over 49. X squared is equal to that whole thing divided by 2, which would just cancel the 2's, wouldn't it? If you imagine that 2 going down to the bottom there, it would cancel with the 2 on top. So we're going to get 16G squared over 49. And you can see you can get the square root of each one of those. X is equal to 4G over 7. So the negative vector is minus 4G over 7 in the I direction, minus 4g over 7 in the j direction, and that's the vector f. The acceleration of f is equal to that. A is just in the positive, g over 7 in the I direction. We're asked to add a plus f together. A plus f is equal to minus 3g over 7 in the I direction, minus 4g over 7 in the j direction, and we're asked to get the magnitude, or what way to describe it in this question? Where is it? The actual acceleration of the particle is of magnitude, so we need to get the magnitude of this. The magnitude of the a and f vectors added together is equal to the square root of 3g over 7 squared plus 4g over 7 squared. You can put the minus parts in if you wish. That's going to be equal to the square root of 9g squared over 49 plus 16g squared over 49. You can see at this point it's simplifying nice for you. 25g squared over 49, which we can get the square root of all of those to be 5 and g and 7 meters per second squared. And that is what we were asked to show. Hopefully 5g over 7. I think I do remember 5g over 7 somewhere in my distant memory of 11, nearly 12 minutes ago. There's the 5g over 7.